Today's topic is section 9.6, and it's calculations with empirical formulas. You've probably seen that what we're doing right now is we're doing calculations that real chemists do. The first type of calculation we're going to look at with empirical formulas is percent composition. So if a chemist had an unknown compound and they were able to get the percent composition, they could come up with an empirical formula to try to help them discover what that compound is. This could be used maybe in a forensics laboratory. This could be used if a chemist is experimenting and trying to make a certain compound to see if they actually made that compound. It might even be they have made something, they don't know what it is, but if they have the percent composition, they can get an empirical formula. So these are real-life calculations that chemists would use. So let's take a look at how we do this. So I have a problem. An unknown compound contains 75% carbon and 25% hydrogen by mass. What is the empirical formula of the compound? So the first thing we do, step number 1, is to assume you have a 100-gram sample. So the compound contains 75 grams of carbon, and 25 grams of hydrogen. We simply change the percent to grams. The second step is to determine the number of moles of each element. So we take our 75 grams of carbon, and we have to figure out the moles. So we use our bridge notation. We know that 1 mole of carbon is 12.01 grams of carbon. Now remember, the molar mass comes from your periodic table. It's just the atomic mass, and we're just writing it as grams instead of a U. Grams cancel out, we're left with moles, so we have 6.245 moles of carbon. Let's do the same thing for hydrogen. So we have 2.500 grams of hydrogen. From our periodic table, we know that there are 1.008 grams of hydrogen and 1 mole of hydrogen. So when we do that division, these units cancel out. We get 24.80 moles of hydrogen. The next thing we do, step 3, is we determine the mole ratio by dividing all numbers by the smallest number. So the mole ratio of carbon to hydrogen is 6.245 to 24, whoops, 0.80. I divide by the 6.245. And I get a ratio of 1 to 3.97. I'm going to round off this 3.97, so my mole ratio is 1 to 4. So my next step, step 4, I'm going to show this to you just to make sure I didn't cut that off for you. My next step, step 4, is to get my empirical formula. And it is, my mole ratio is 1 carbon to 4 hydrogens, but remember we don't write ones in our formula, so it's CH4. So that is how to start with percent composition and get an empirical formula. The second type of problem you might encounter is going from mass composition to the empirical formula. So here I have a 5-gram sample of an unknown compound contains 1.844 grams of nitrogen and 3.156 grams of oxygen. Find the empirical formula. For this problem, I'm going to start at step number 2 from the previous problem. It's always nice when you can cut out a step. And so I am going to start with just the masses. 1.844 grams of nitrogen, and I want to find out how many moles there are. So I know that 1 mole of nitrogen from my periodic table is 14.01 grams of nitrogen. That cancels out. I'm in moles, so I have 0.1316 moles of nitrogen. Going on to my oxygen, I have 3.156 grams of oxygen. From my periodic table, I know that 1 mole of oxygen is the same as 16.00 grams of oxygen. Remember, when I'm doing my bridge notation, they have to be able to cancel. If I have it on the top, it then has to go on the bottom. And I get an answer of 0.1973 moles of oxygen. I then do my mole ratio. So moles of nitrogen to moles of oxygen are 0.1316 to 0.1973. I divide each side by the smaller number, which is 0.1316. And I get a ratio of 1.000 to 1.499. Now, I can't leave this like this because this is 1.5 really if I round it off. So if the ratio is not close to a whole number, express the numbers as fractions and multiply by the common denominator. So for this example, I would say 1 to 1.5 equals, I know that 1.5 is the same as this fraction 3/2, so I would put 2 over 2 to 3 over 2. I would then multiply by 2 over 2 for each one, or by 2, excuse me, to get rid of the denominator. So 2 over 1 times 2 over 2. And that would give me 2 to 3. Therefore, my empirical formula is N2O3. And there's one last type of problem we can do. That is converting percent composition to a molecular formula. So a problem we might have for this is caffeine is 5.170% hydrogen, 16.49% oxygen, and 28.86% nitrogen, and 49.98% carbon by mass. The molar mass of caffeine is 194.20 grams per mole. Find its molecular formula. For this problem, we start at number 1 from the first problem. So we take our percentages and we just assume that they are masses. So we take for our hydrogen 5.170 grams of hydrogen. We convert that to moles, so we know that 1 mole of hydrogen has a mass of 1.008 grams of hydrogen. We get that from our periodic table. That cancels, and we get 5.129 moles of hydrogen. We do the oxygen, so 16.49 grams of oxygen from up here. That's our percentage. Just changing our percentage to grams. We know that 16 grams of oxygen are in 1 mole of oxygen. When we do that division, we end up with 1.031 moles of oxygen. Now notice I'm keeping 4 significant digits for all of these. All of my numbers have 4 significant digits. For the nitrogen is 28.86%. I convert that to grams, just write it as grams of nitrogen. I know that 1 mole of nitrogen is 14.01 grams of nitrogen. Remember to cancel these out. If it's on the top, it has to be on the bottom, the same label. And I get 2.060 moles of nitrogen. For the carbon, I'm given 49.98 grams of carbon. I know that 1 mole of carbon is 12.01 grams of carbon. And so when I do the division, I get 4.120 moles of carbon. So then I have to do the mole ratios, but this is a little more complex. So what I'm going to do is I'm just going to go through and divide everything by the smallest number. The smallest number is 1.031. So I'm going to start with my hydrogen, and I have 5.129. I'm going to divide that by 1.031, and I get an answer of 4.974. I'll do the same thing for oxygen. 1.031 divided by 1.031, because that is the smallest number, and I get 1. For nitrogen, I have 2.060. Divide that by my 1.031, and I get 1.998. And for my carbon, 4.120 divided by 1.031 is 3.996. Now, all of these round off very nicely. So my empirical formula is, starting with carbon, C4, H5, N2O. And so that's how I go from percent composition to molecular formula. One last thing here, I'm going to do the problem from page 227, problem number 9 for you. And then you should be able to do your homework. So the problem on page 227 says, find the molecular formula for acetone, molar mass of 58.0 grams per mole, used to make nail polish and other industrial products. Its composition is 62% carbon, 10.4% hydrogen, and 27.6% oxygen. So my first step for that is to just assume that those percentages are masses. So for the carbon, I have 62.0%, so I'm going to write 62.0 grams of carbon. I know that 1 mole of carbon from my periodic table is 12.01 grams of carbon. So when I do that division, I end up with 5.16 moles of carbon. For my hydrogen, I'm given that it's 10.4%, so I'll write that as 10.4 grams of hydrogen. I know that 1 mole of hydrogen is 1.008 grams of hydrogen from my periodic table, and that's 10.3 moles of hydrogen when I do my division. Now notice on this problem I have 3 significant figures because that's what they gave me to start out with. For my oxygen, I have 27.6 grams of oxygen because they gave me 27.6%. I know that 1 mole of oxygen is 16.00 grams of oxygen from my periodic table, so I get 1.73 moles of oxygen. Now I have to do my percentages, or my ratio. So I'm going to go back and look, and this is the smallest number, so I'm going to divide all the numbers by 1.73. So for carbon, I'm going to divide 5.16 by 1.73, and I get 2.98. For hydrogen, I'm going to divide 10.3 by 1.73, and I get 5.95. And for oxygen, I'm going to divide 1.73 by itself, and I get 1. And notice all of these round off nicely to whole numbers. So my empirical formula from this becomes C3H6O. But I want to get to my molecular formula. So I have to find the molar mass of my empirical formula. My molar mass of C3H6O. So for my carbons, it's 3 times from my periodic table, 12.01 grams per mole. So I get 36.03 grams per mole. For my hydrogens, it's 6 times 1.008 grams per mole. I get 6.048 grams per mole when I do the multiplication. And for my oxygen, it's 1 times 16.00 grams is 16 grams per mole. When I add all of those up, I get 58.07 grams per mole. Now, in the original problem, I was told that the molar mass of acetone is 58.6 grams per mole. So I divide 58.0 grams per mole by 58.0 grams per mole, and I get 1. So that means I don't have to change anything. My molecular formula is the same as my empirical formula. And so that's how you do those problems. Now, don't freak out on your homework. I know there's a lot of steps. I just showed you 3 different kinds of problems. They're all very similar. You have these to look at. Just figure out what you're doing, what you're trying to go from to. Are you going from percent composition to molecular formula? Are you going from percent composition to empirical formula? Or are you going from mass composition to empirical formula? Just figure out which one it is and use your sample problems to guide you. I will be putting up your homework next.